Something a little bit different today. 2 electric bikes. These are from the Chinese company QMWheel, rebadged and sold in the UK as Ride GB. Got a pair of them off eBay with a whole box of spare parts, which is quite handy, both with faults, motor not running. I've already fixed this one. So that one's ready to go, but the other one is sitting over there and it has the fault where the motor will energize and it'll just vibrate, it won't spin freely. I'm hoping the fault is the same as this one, so I thought I'd just document it as we go through. And in an act of seamless editing, number 2 is now on the bench and I'll show you the fault. I've taken the side panel off so we can get to some bits. Power on and turn the throttle. Running really rough. And no power. As soon as you put any load on it, just cuts out. So this is all the wiring from inside the e-bike. Separate it out. The motor wire is going to be this one. You can always tell because it's got the 3 fat motor wires going to it. The corresponding Hall effect sensors and 5 volts to them. They'll go down the same wire. So what I'm going to do is just check the resistance between all of these pairs here to make sure they are sensible. I'm looking for something less than an ohm, but if one is open circuit, we know the motor is faulty. Also going to check backwards into the controller, both to supply positive and ground. Continuity test on each of those. That will tell us if any of the MOSFETs have blown in there. And if all of that looks okay, we're going to spin the motor, power it up, and have a look at the Hall sensors to see if they're faulty. Let's do those one at a time. Okay, I've got my meter set up now, set to the ohms range. Connect my probes together, read the lead resistance, 0.1, 0.2 ohms, that's okay. I'm going to measure the resistance between the 3 windings of the motor. They're wired in like a triangle configuration, so I should read the same between any pair that I look at. I'm expecting less than an ohm. This is a 250 watt motor, 36 volts, so less than an ohm would be sensible. Let's go blue to yellow and get a good contact. About half an ohm. Let's go blue to green. Half an ohm again, and green to yellow. Half an ohm again. So all 3 of those are reading about the same, about what we expect. That says there's no burnt windings in the motor, no open circuits, no short circuits. That's a good start. And now we're going to check the MOSFET outputs. So I'm just going to switch to continuity range. And I'm going to check between 0 volts, which is the black wire on the power supply, to each of the outputs from the controller. And they're all reading okay. They're all open circuit. If it's short, it would beep and do that. Put the red wire on the positive. And check again. Good, good, good. And we can probably back check the diodes that are built into the FETs if I go the other way around with the probes. So I've got the black wire on the positive and the red wire going in, and that'll go backwards through the diodes in the driver. So I should get conductivity in all of those. Great. So that's telling me in all instances that the MOSFETs are not shorted and the diodes are correct in there. So I've got a good motor, got good MOSFETs, the plot thickens. Okay, so I've changed the scope meter into scope mode now, so we can just look at the outputs. I've just got these hooked up to yellow and green for now. I'm going to spin the back wheel, and what we should see is some kind of sine wave coming out of the motor. So I'm just going to lift the rear wheel off of the deck, give it a spin. Yeah, nice big sine wave coming off that. Let's check another pair. Let's check yellow-blue. Yep, nice sine wave coming off there. And then we'll just check blue-green on there. Great. So that's just using the motor as a generator. And it's just showing us again that all of the coils are looking pretty healthy. So the last thing to really check is to power it up and have a look at the Hall sensors coming out of the motor driver. Okay, so let's get everything plugged back in, ready for a Hall sensor test. So just plug the motor wires back in, matching the colours up as always. So I'm only really interested in that one motor wire at the moment. All of these other things, the brakes, the lights and things like that, not interested in those at the moment. They're not going to be concerning me. Let's put the power back in. I'll just reconfirm that the fault still exists. Yeah, still sounds awful. Right, I'm just going to get some probes hooked up. What I'm going to do, looking at this same wire again, we've got the red and the black, which is 5 volts and ground to the hall sensors. And then we've got the output of each hall sensor coming back. So I'm going to get a ground connection in there for the scope probe. And then we're going to try and get onto each of those. So I'm just going to put some wires in the back of there and get set up for that. Okay, so it's a pretty hokey setup. I've just jammed a bit of wire into the black wire there for the ground and a bit of wire into the yellow wire there so we can look at that signal. What I'm going to do is just spin the back wheel by hand and we should see some pulses appearing on the scope meter. There we go. So that's the hall sensor on the yellow wire. So let's move that across to the green wire. Nothing on the green wire. Interesting. I can tell we've got a connection because when I pull the probe out, it goes to 0 volts. So it looks like we have no signal from the hall sensor. Let's check the blue one. That has a good signal. Okay, so the fault is we don't have a hall sensor on the green signal. That will stop the controller knowing what's happening and it will make the whole thing vibrate, which is exactly what we're seeing. So what we need to do now is to trace that green wire from there back to the motor and see if there's anything obvious which could be causing it. We may have found the culprit quite quickly on this one. There's a couple of clips here that this wire clips into. This is the motor wire, and you can see it's torn apart, gone through the insulation in 2 locations there. So my guess is if we strip that back a little bit, we're going to find a broken green wire. We don't even have to take the motor off or apart. Let's just investigate further. And that did not take very long. Just cut that first bit of wire back there, struck gold straight away, broken green wire. I'm going to go back to here and check this part as well because it's likely something's got damaged in there. But yeah, so we're just going to solder those two back together, get some heat shrink on it, get some amalgamating tape, and we'll go back and check if we've got a signal. Definitely some of my finest work there. I've paired the green up with a beautiful orange red that I had lying around. I think that came from a Ford Focus I had once. Right, let's connect it up and see if that's fixed the problem. Okay, so we've got the same connections back to the green hall and the ground that we had earlier. I'll turn the power on, lift the back wheel and just rotate by hand. Yeah, and we've got pulses now. So we should be able to turn the throttle and get a smooth response. Just like that. Working beautifully. Right, let's get that wire taped up, take her out for a test run. So that's the repair complete, all covered up with some self-amalgamating tape and a safety cable tie. The side panels are bolted back on. Time for a road test. As I said earlier, these came with a whole load of spare parts, including a spare saddle with a clip on it. I need that in a moment. Spare brake caliper, brand new. Spare front wheel, some seat post extensions, spare set of brake levers, a chain, tyres and inner tubes, brand new, bunch of inner tubes, a user manual, mud guards, some spare kickstands, a spare battery box, unfortunately no battery in that one. Another saddle, and a spare disc brake. Not bad. I need one of these saddles now though. Well, it works. And it's got cruise control. Excellent. Effortless. Battery. And just for the record, this is bike number 2. Exactly the same problem. Blue wire had been cut with these clips in the frame. No hall sensor on the blue winding. Didn't work. And now, there's the throttle. And nice and smooth. Another good fix.